The catastrophic disaster on Boxing Day back in 2004 was triggered by one of the largest earthquakes ever recorded that claimed around 230,000 lives across 14 countries. But what caused the quake and why was it so destructive? Syahida Othman explains.
To understand the scale of the disaster, we need to look at the forces beneath our feet. The tsunami was caused by the movement of tectonic plates. The Earth's surface is made up of large plates that float on molten rock. Now, these plates are constantly moving, and where they meet, powerful forces are at work. The 2004 earthquake occurred along the boundary between two of these plates. Over time, stress built up as the plates pushed against each other. Eventually, when that stress became too great, nature's fury was unleashed. The resulting release of energy was catastrophic. It displaced huge volumes of water, triggering the deadly tsunami waves that followed. Understanding how it happened is key to preventing future disasters. Scientists study tectonic activity to identify earthquake-prone areas and improve early warning systems. While we cannot predict exactly when a major earthquake will strike, knowing which regions are most vulnerable can help authorities issue timely warnings. This gives people crucial time to evacuate and prepare, which can mean the difference between life and death. Thanks to advances in technology and better public education, we're now better equipped to respond more quickly in the event of another major earthquake. And knowing the science behind these events is vital in making sure the tragedy of 2004 never repeats.
All right, for more, we are joined by Diego Melgar, Associate Professor at the University of Oregon's Department of Earth Sciences. Professor, thank you very much for joining us. I understand that your research focuses on the physics of earthquakes. What makes certain earthquakes more likely to trigger devastating tsunamis like the 2004 incident?
Thank you, Julie, and good morning to all of you in Southeast Asia. It's the sheer size of the earthquake. In the case of the 2004 event, it's so long and so large that it just has the natural ability to move the ocean floor, move the seawater, and that's what causes that big tsunami that everybody saw.
And Professor, are we getting any better at predicting earthquakes and tsunamis these days compared to 20 years ago? My observations, and I have to stress they are very casual, not so good when it comes to actually predicting an earthquake. We can detect a tremor when they occur, and we seem to be, much improved in terms of sending out tsunami warnings and alerts. Am I on track?
You're absolutely on track, Arnold. That's a very astute observation. We're very far away still in seismology from prediction. And just for your viewers, prediction means actually telling people the size, the date, and the location of an event hours, days, weeks, or months before it happens. We're very far away from that, and usually any claim of prediction comes from social media, and 99 times out of 100, it's totally unfounded. Now, when it comes to forecasting what the tsunami will look like if it happens, we're getting quite good at that. So now we have the ability to say when the earthquake happens, the tsunami will likely be of this size or will have this intensity in these locations. And that's a significant improvement from 2004. In the last 20 years, we are much, much better at modeling with computers what the earthquakes are going to do, what the shaking is going to be, and what the tsunami impacts will look like at specific locations.
So what are the emerging patterns in seismic data that can help us predict future earthquakes and tsunamis, and how might this improve countries' preparedness and reduce the impact and save more lives?
Julie, I really want to stress that even though prediction is still really far away, we need not wait for prediction to be prepared. We can prepare now. And there's many ways in which societies prepare for earthquakes. Early warning systems, as were mentioned in the lead into the story, are one way, but there are many other ways. Earthquake building codes, so that buildings are built not to collapse during strong shaking. Preparation, so that when the tsunami comes, we know exactly what to do. It's extremely striking to watch the footage especially from Aceh in 2004. And after the strong shaking, people are not evacuating. Everybody's standing around trying to help get people out of collapsed structures when everybody should have been moving, evacuating. And so that kind of education can do more to prepare folks than any kind of prediction ever could.
So, Professor Melga, I just want to, pick up on this particular point. I mean, the technology is one thing, as you just pointed out. I want to ask you about things like regional coordination and, I guess, efforts to build community resilience. I mean, can you stress to us how important it is, in terms of being prepared, as you mentioned, being prepared to face tsunamis, given that we can predict them. I mean, what will happen if they happen, when they happen, with greater accuracy these days?
You've hit the nail on the head there, Arnold. Thank you for that. Yes, these events are so large that they affect many nations. In the case of 2004, we saw impacts in Thailand, in Indonesia, in Sri Lanka, India, as far away as Somalia in Africa. And so without regional cooperation, both for the planning, for the deployment of instruments, for data sharing about the earthquakes when they happen, without that kind of multilateral regional collaboration, it's very difficult to be prepared for events like this. And this is true not just in Southeast Asia, it's true in South America, it's true in the South Pacific. It's regional collaboration because these are hazards that affect many, many nations. And so that's where I think many major improvements have happened. Countries openly share their seismic data. That's not something that was happening in 2004. And so that makes it easier to alert folks when tsunamis happen. It also makes it easier to share knowledge and information in terms of computer models and training and preparations so that overall, the entire region can be lifted and made more resilient rather than just this country or that country.
Professor, given the threat of climate change and the warming planet, how might this impact tsunami risks in the future?
Thank you for asking that, Julie. That also is an emerging topic in research. A 1 meter tsunami, which might not seem very hazardous if it happened today, will potentially be a 2 meter tsunami or a 3 meter tsunami if it happens 100 or 150 or 300 years from now as sea levels rise. So unfortunately, the truth is that with increasing sea levels, tsunami impacts will become progressively deadlier. And that's something that we're starting to take into account when we make preparations and calculations and we start to say to folks, this is what you can expect in future tsunamis. We are now factoring in rising sea levels. And we're also doing other advanced things like factoring in how land uses are changing. We're having folks live in places that used to be mangroves, that used to be uninhabited, but are now inhabited. So in our calculations of how societies are exposed to tsunamis, we need to take into account those variables as well.
Professor Melga, given what you've just said and what you've just said, I beg your pardon, and all that has happened over the past 20 years, can we be confident enough to say now that if a similar magnitude earthquake was to strike again, similar meaning more than 9, and was to produce the kind of tsunami we saw back in 2004, it would undoubtedly still be disastrous, but are we in a better place now, both pre and post-event, if you like?
We're in a better place, absolutely, Arnold, but we're not at our destination. So one can envision that if an earthquake like the one in 2004 were to strike today, perhaps we'd be fortunate enough to not have 260,000 people die. But indubitably, we'd have tens of thousands of people still die. Because the nature of these phenomena is that they are few and far between. And so as time goes on, the memory fades and the memory is lost of these events. And so preparations will become a little bit more lax, will become a little bit more complacent. And in some cases, we forget entirely about the event. It might seem unfathomable now to people in Sumatra and in Thailand, for example, but that's what happens. And so that's what we see right now in the US, for example, in the place where I live. We know magnitude 9 earthquakes are possible, but we still struggle to get society to jump into action. So yes, we're definitely in a better place, but we are not ready for the next magnitude 9 just yet.
And Prof, would you say that that's the greatest danger, simply that we are going to forget the last disaster and what happened and what we need to do to be prepared?
I wouldn't say that's the greatest danger, but that's certainly a danger, because geologic phenomena happen at the scale of decades and centuries, and for humans, that's difficult to fathom. We see it with climate change, right? the scale of the change is sometimes gradual and slow. And so when election and political cycles are 2 and 4 and 6 years long, it's hard to take action at the scale of 50 years and 100 years. That's the challenge we face with large earthquakes and tsunamis, thinking generationally. We must think not about the following election. We must think about our children and our children's children. That's the kind of mindset that will truly allow us to make it so that tragedies like the 2004 one never happen again.
And we are some ways from that, unfortunately, I believe. Professor, we do have to leave it there. We thank you so much for your time and for your thoughts. That was Diego Melgar, Associate Professor of Earth Sciences at the University of Oregon.